Okay, I'm going to try and show you how to do this method as quick as I can. Basically, how to spot the primes and factor all the numbers. Now we don't care about the factors. Okay, we only want the prime numbers, right? And in the other video, it showed you the same thing. Pretty much, I'm going to show you now. So I'm going to initialize 3 here. Okay, so 3 squared is equal to 9. 3 squared is equal to 9. Okay, so I go find 9 and I put a 3 here. Okay, and then I basically start counting down backwards. 2, 1. Now, before I go any further, you always initialize 2 values at the same time. And when you've reached that value, okay, then you initialize the next value. So I should have actually done 3 and 5. Okay, but well, I didn't know if 5 was prime or not, but we know 5 is prime because there's nothing here. It's null. So we're going to initialize 5. Okay, and put 5 over here. Okay, square it, and it equals 25. Okay, and we look down for our 25 mark here. Okay, 25. I'm marker 5 here. Okay, 5 has been initialized. All right. Now, how you create the end table is up to you guys. I really don't care. But we're just generally going line by line. So I create the end table at the same time that I've done this. I've initialized my 3 until I reach 25. So I'd have a counter telling me when I hit 25, start taking 1 away from 5 until it reaches 1, and then back to 5 again, decrement until it reaches 1. Okay, so, and then once I hit my 5, I initialize my next prime, which would be a 7, but I haven't hit my 5 yet, so I don't initialize my 7. Okay, so 3, 2, 1, and then 3, 2, 1, 3, 2, 1. Okay, hit my 5. Now I initialize my my 7 over here. Okay, so 7's 49. So 7 times 7 here. Let's go over here. 7 squared equals 49. 7 times 7, whatever. Okay, so this takes a very odd number here. Okay, so we go down to 49. Right there. And we go and we initialize our 7 here. Okay, now to speed this up even faster, okay, now we got 2. We always have 2 on the go, right? Two primes on the go. So you know this is prime, you know this is prime, right? Okay. Now what we do is we spot our non-primes. We know this is not a prime because it's a 3. B1 is equal to 3. So we put 3 up here too. We put 3, we put 5, and we put 7. Okay. So when B is equal to B, is an iteration, right? You know it's not prime. Okay. When it's not equal to, it could be a prime. Okay. If there was a value next to it. But here there's no value next to it, so we know this is a prime. Okay, so we circle it, right? We know this is a prime, and we start in our registry up here. Okay, it goes up there, right? And but we don't initialize it. Okay, so I'm doing the best I can. I'm not going to write the pseudocode for you or the flowcharts. You guys are going to have to figure this shit out and make it faster. Okay. Now what I do, I'll try and show you an example here as fast as I can. Okay, 3, 2, 1. Okay, 3, and then we go 4 because you go line by line, right? And then there's nothing here, it hits null, so you don't do anything because you check and it's down here, so at 49, right? So you know that this guy here is 3. B is equal to 3 is equal to 3, so 27 is not prime. Okay, so but we go down here and it's 2, and there's a 3 there, right? But is B 3 equal to 2? No. Okay, well, possible prime. Is 3 equal to 5? No. That's means that's a prime. Yeah, we got a prime in it. Okay, so we keep going further. 2, 1, 3, 2, 1, 3. We do go line by line. Sorry. So 3, 2, 1, 5, 4, 3, 2, 1, 5, 4, 3, and you go. And if you would go line by line. I'm just filling this fucking shit out to get your programmers to figure out how to do that. And basically do that here. So we're going to spot our prime. I don't give a fuck about the primes. I just want to hit 49. So I got more to play with here. I go 2, and I go 2, and I go 1, and I go 1, and I go 3, and I go 5, and I go 2, and then I go 4, and then I go 1, and then I go 3, and I always do my check too, right, to see if I'm at my 49 level. I'm at my 49 now. Wow. So now I start decrementing my 7, right? Okay, and I know the next number is null, so I don't have to check, but I check anyways, because it's just what you might want to do. I don't know. Let your developers figure that out. So you got 6 here, we're starting to go 3, and you got 2, and you got 6, and you got my camera's in the way here, and you got a 2, and you got a 1, and you got a 5. Okay, so you know this fucker here is prime. Okay, okay, but this is what I wanted to show you here exactly. So I'm gonna rub this out. Okay. This is what I wanted to show you. Speed things up a little bit. This is the part that speeds it up. Okay. This is the magic. Okay. Now, okay, we've hit our 3, right? We know B is equal to 3 is equal to 3. Okay. So we know that this is not a prime number. So we don't want to go any further and waste our time filling out thousands of fucking digits, right? So basically we skip this. We just forget all about this. We still know what 3 is. It's 3, and we still know it's 7, right? These values here, okay? But our next value here is going to be a 2, okay? So we decrement by 1, okay, 2. But these values here, because we fucking didn't, whatever, we basically subtract by 2 now, not by 1. Okay, subtract by 1, it's going to be subtracted by 2 because we skipped this area. So now we're down to 1 again, okay, and then we're from 6 to 5, okay. Now we got 2, 1, 5. Now we know this is a prime, okay, 2, 1, and 5 there, okay. So yeah, basically that's it. That's the fastest way. So when you've reached your like initialization, right, you don't have to fill out the whole table anymore here. You don't have to fucking do that. You just do n or not n, sorry, b minus 2, okay.